It's time for pure performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello and happy Cinco de Mayo, everybody, or belated Cinco de Mayo. As you all know, we like to record these ahead of time, but today is actually Cinco de Mayo, and my name is Brian Wilson, and we have, as always, Andy Grabner. Hello, Andy.
Hey, and it's actually one day after May the 4th be with you, right? It's actually very interesting
That's
that
right.
These two significant days are so close to each other.
It is. There's a lot of great pictures from May the 4th.
Yeah.
The funny thing about Cinco de Mayo, at least in this country, is are you familiar much about what Cinco de Mayo is really about?
Well, what I know, I think at least it's the Mexican national holiday, right? I would say national day, yeah.
Well, it's a holiday, yes.
Yeah.
It's a very safe answer.
And I guess the people in the U.S. may just use it as an excuse to get drunk. I don't know.
Yeah, that's basically it.
Yeah.
A lot of people also think it's Mexican independence, but it has nothing to do with Mexican independence. It was a Mexican holiday celebrating the Battle of Puebla. May 5th, 1862. And yes, I do have Wikipedia open in front of me right now.
Wow.
But the had nothing to do with Mexican independence. Basically, they beat the French out of a town. And the reason the United States back then was happy about it is because we were looking at the French as possibly encroaching into the United States from Mexico. So with Mexico beating the French out, we kind of saw that as a little bit of an extra safety net, probably before we took over a lot of Mexican land in what is now the United States.
Yeah. And so basically I learned a lot, and hopefully our listeners also learned a lot what they didn't even sign up for, right? I mean, it's good.
Yes.
It's an historical fact, right?
Yeah, but the reality is it's just a bunch of people go get drunk.
Yeah. Well, we have a party here today in the office.
Mexican beers.
Yeah.
Oh, you do for Cinco de Mayo?
Yeah, we do. We have. Am I allowed to say that? I'm sure I am. So starting at 3:30, which is about in an hour, we have 2 margarita machines, and we have some Mexican beer, and we also have craft beer, U.S. craft beer on tap. So that's what I'm saying. People just take it as an excuse to get trashed.
Yes, especially at work.
Hey,
I do not have any. I don't have any Mexican beer here.
No, well, we can fix that. Go to a store, buy something.
Oh, it's almost. Oh, it won't be served while we're still recording this. So
that's true.
Unfortunately, you can't help it. Enhance this week's episode. Yeah. So this week's episode, what are we talking about? .NET performance.
Exactly, because I think last week when we did the recording, we talked about Java performance. And
it might not be a week, but last episode, yes.
Last episode, that's right. But I mean, it's still fresh in my memory. We were sitting in Denver in a hotel and recording it. Now we're half a continent apart. Yeah, we're talking about .NET performance. Why .NET performance? Because we obviously, from a Dynatrace perspective, the two major technologies we see is Java and .NET. And I think there's a lot of myths about Java and .NET performance, especially in .NET, because there's so many things that can just equally go wrong as with Java. And I think when we did a little chat before we got started, we also said there's also a lot of, let's say, things you cannot control as a .NET developer. You think you are not under control as much as in Java, because Microsoft tries to make it very easy for developers to write code and then run the code, and then they just take care of it. And there's some really interesting things, especially if you run apps in IIS, which I believe most of the apps that are ASP.NET apps, web apps, or services run in IIS. And there's a lot of stuff that Microsoft takes care for you, like automatically recycling the app pools in case you do something stupid, you run into a memory leak and things like that.
Yeah, and there are a lot of benefits. I like to knock .NET just because that was the main programming language I was working with back when I was running performance testing, and it always just seemed to have issues. But it's, I guess it's easy to knock Microsoft. But there's actually a lot of great things that it does for you. And a lot of that management really takes some of the guesswork out. But I guess the difficult part is when you do run into those issues, finding out how to actually take back control over those components. Mm-hmm. So hopefully we'll bring up some interesting ideas for you and help you all, point you all on the way to how to address some of these things. What are some, before we dive deep into them, what are some of the, main issues that you see? I don't know if we're going to address them all today, but, let's get a list because we are going to keep revisiting this topic until we exhaust them all. Mm-hmm. What do you see as quite a lot of the .NET performance problems?
Well, if I look back at the last 12 months, so I think I mentioned this before in some other episodes, whether we have the Dynatrace free trial that everybody can register for, and which converts to a personal license. So in case you don't know, bit.ly/dtpersonal. And Brian, you want to do me the favor and repeat that because my strange Austrian accent might not be that clear?
Yes, but mine might be just equally as unclear to anybody who's not listening in the United States. So I'm expanding my worldview and admitting that I do not have the normal accent. So yes, bit.ly/, what was it?
DT Personal.
That's right, DT Personal.
Yeah. So basically,
I have a very short memory span.
It's okay. So people sign up for the free trial, and part of the free trial, and then the personal license is an offer that I make, is sending data to me. It's called Share Your Pure Path, and people have shared their Pure Paths with me in the last 12 months. I got 200 people sharing their Pure Paths with me, and a lot of them were .NET Pure Paths or Pure Paths from .NET applications. And back in early last year, actually, I just looking at the blog here, I wrote a blog on C# performance mistakes, top problems solved, and I list a couple of them. And one of the things that if I just read from top to bottom, wrong sizing of available worker threads, that's one thing. Loading too much data from a database, excessive use of database connections, expensive string concatenations, high memory usage, too many background threads, too many asynchronicity, and just like excessive on exceptions. So these are some of the things that I see. And it's actually not that much different from Java, I would say, where we suffer all from the same problems, even though we always point the fingers to look at the Java people, they don't know how to write code. And the Java people say, look at them strange Microsoft people, they don't know how to write code. But in the end, we all write applications, and we all suffer from the same problems, either having a bad architecture and coming up with just too many communication, too chatty between either the application and the database, or now between services, sending too much data over the wire, or if you build web applications, just building pages that are just totally overloaded. And in order to communicate from one tier to another, we have typically some type of connection pool. We have in a multi tier environment, and also in a multi-user environment, obviously we have threads that are executing all of our requests. So that's where we need to look at thread pools and connection pools. And the other highlights that I had here is memory leaks, memory usage, high garbage collection, doing stupid things like very expensive string concatenation. So instead of using string buffers or string builders in .NET, just building them through string objects. I mean, some of the stuff the compiler already optimizes for us, but still, I've seen very strange, interesting things. So there's a long list, and if people want to read more about it, I say go to the blog.dynatrace.com and search for
it's APM blog, right? I think it's APM blog.
Correct. I think if you enter blog dynatrace.com, it will redirect, so you will find.
That's the old URL.
Exactly.
Back when we were Dynatrace.
Yeah. Well, we are. What's wrong with you? So basically, a long list of things, and I think we said to keep in a single episode, let's say digestible. We want to focus on two things, right? At least we try to get through at least two things. What was that? Can you remember me?
The managing your worker thread pools, and we were going to tackle database. But I think we may even find that the database topic, you mentioned several database problem patterns there already. So we'll see what we can get through on that. Of course, for all of our listeners, we are going to once again address the most beloved database problem out there, the N+1 query issue. But it's interesting that there are several other database issues in those things. Not just .NET, I would say, but looking from that blog that you had written, there are some more fun ones, and I really liked the idea of leveraging the stored procedure, but we'll get to that when we get into the database. Let's start with the worker threads, though. And well, why don't you tell us what you've seen?
So the number one question that I always get, people that use Dynatrace, and I think most of them actually deploy an app, typical on IIS, because it's either web services that they have to deploy or web application, and then they show me the pure path. And if you know the pure path starts in this case on IIS, on the native layer of IIS, and then IIS takes the request that comes in from the browser or from whoever consumes that service, and then it's going through the list of modules, the native modules, and then eventually it passes it over to ASP.NET. So, and the most common question that I get, and people say, why does Dynatrace show me a lot of I/O time in IIS before it's passing it over to ASP.NET? This doesn't make sense to me. Why do I see all the time in IIS? What's happening there?
I ask that a lot myself.
You're really funny today. Huh? Did you already have some margaritas today?
No, I didn't.
Oh, really?
But I've been having I'm back on my diet of vegetable and fruit shakes. So maybe without all the extra junk in me,
well, maybe
my brain's a little sharper.
This green healthy stuff maybe starting to in your digestion tract, maybe to start to build some alcohol. Who knows? Right? Fermenting.
Right.
Maybe somehow you get. Anyway, let's go back to the topic. So here's the problem. If you look at IIS and if you look at ASP.NET, that means IIS natively is handling the incoming requests, and it then needs to forward the request to the ASP.NET Worker thread or to the ASP.NET Worker engine. And if you have, let's say, 1,000 requests coming in, and you only have, let's say, 50 threads in ASP.NET, well, guess what happens? All these 1,000 requests cannot be handled at the same time. The first 40, 50, 60, whatever can be handled. And depending on how fast you are in your ASP.NET processing, you can handle these requests rather fast. But if you're slow, that means IIS needs to pool these requests. It basically blocks the request on the native part before there's a new free worker thread available in ASP.NET to pass it over. And this is typically when we look at the pure path where we see request comes in IIS, and then it takes a huge amount of time before the request gets passed over to ASP.NET. What I always like to look at, and this is also the number one finding that I have in my blog that is called C# performance mistakes, I look at the elapsed time column. So the elapsed time column is a column you can turn on in the pure path tree, and it shows you when did this particular request actually hit a particular tier. And you see the elapsed time column starting with 0 on IIS, and then typically it takes milliseconds before it gets passed over to ASP.NET, but it could be seconds. And the first example that I have in my blog, it actually took 87 seconds until IIS was able to pass that request over to the ASP.NET worker thread or worker pool, and then it's clear, hey, there's something going wrong. So typically, it's either there's too many requests coming in IIS and not enough threads on ASP.NET. The other thing that could also happen is that you have some native modules in IIS that are either doing redirects, encryption, authentication, compression, decompression. If you have a lot of these native modules, it could also be that some of these native modules actually cause slowness. In this case, I typically recommend to use the failed transaction tracing feature of IIS, which actually breaks down how a request is actually moving through the individual native modules and where maybe native module is taking space. But typically, I see the problem of too many requests coming in and not enough worker threads available in ASP.NET. And the question is, can we increase the worker threads? I think Microsoft itself, they have like a little rule internally, depending on the number of cores you have on your machine, on how many threads are actually by default spawned. But I believe, and Brian, maybe you know that better than I do, there's an option to actually configure the number of worker threads.
Yeah, I was just looking this up earlier today because one of the biggest issues I've always run into when you hit .NET problems that are especially around threads, memory, and everything else is the common response is, well, .NET handles all that. That's not something we have settings to do. Whereas in Java, in the Java world, or should I say in the Java world, you're manually setting almost all those settings, if not 100% of them. I'm not exactly sure the coverage there. So the important thing to note, though, and again, your search engine is your friend, is look these things up. And I just came across today, there is a way to override via code in the more recent versions of .NET. I believe there are two commands. One would be get max worker threads, and the other one's set max worker threads. So programmatically, you can handle that. But again, it then comes down to a code change in order to do this. So it's not an easy way to fix it, but there are ways to override those .NET settings and controls. And I believe you were just saying earlier that there's going to be a lot more control possibly coming out in the later,
exactly,
in the next version of .NET.
Exactly. Yeah, Microsoft is actually, based on what I heard, is that they are opening up a lot of the configuration options. Another big topic, even though it's not related to threads now, but memory management. Right now in the Microsoft world, like you have no control about how large are the individual heap spaces or the generations. And I think this is something they want to change, I guess, to learn from the Java world. But another thing, this is
go ahead.
Yeah. So then, what you said
there's two things I want to revisit on what you said, but you finished this thought here.
So what you said there's a way now to override the max worker threads programmatically. That's great. Another option that you obviously have in IIS is to use web gardening. That means in an app pool, you can say, I don't only want to have one instance of an ASP.NET engine running in an app pool, but I potentially want to scale it out. So if IIS actually detects, hey, I can only feed so many requests to an individual app pool because there's only, let's say, 50 worker threads available, then maybe we just launch additional instances, and that's called web gardening. I believe they still call it web gardening, where you can say, I want to just spawn additional app pools and therefore then distribute the load across more ASP.NET engines that can then handle this load in parallel. But, we are a performance company. So there's two options that you have. If you have too many requests coming in, it's like if you go to security on an airport, right? You have 5,000 people trying to get in, and then you have one line open from TSA. Then you're frustrated. So what can you do? You can either create more lines, which makes a lot of sense, right? Instead of one lane, having 5-10 lanes, or you can speed up the process of individual people going through the security check, like optimizing the time. And that's just the analogy would be optimizing your ASP.NET code, because if you don't take 1 second, but maybe you can optimize your code and it just takes 500 milliseconds to execute something, you basically increase the throughput by 100%, and therefore can get more requests through your ASP.NET worker process.
Right, and the important thing there to consider is if you're Apple gardening or creating more worker threads, instead of and only doing that and not addressing the performance of the system, guess what? You're using more memory. You're going to need more computing power. But I think the memory would be the scariest one, because it would be very tempting to just say, oh, increase the thread pool size, right? Yeah. But you have to look at your memory utilization. You have to look at the memory availability on excuse me, on the machine. So it's not just as simple as turn something up. You always have to look at what the effect of that is.
Yeah, what the cost.
Yeah. So I wanted to go back to a couple of things back when you started talking about worker threads. First one, and don't mean to put you on the spot here if you're not 100% sure, but it almost sounds like one of the metrics that might help you with the worker thread exhaustion would be one that's very commonly monitored in performance testing, which is your request queued in ASP.NET. Is that going to be the same metric to show you the same idea, so that if you are seeing a delay in here, you can cross-check it with request queued and put those two together?
Yeah, so ASP.NET has a great number of performance counters, and actually one, I probably need to bring it up here, but there's a request in the queue. Yeah, so request queued is a great metric to watch, because if you see that number go up and up and up and up, well, we have an issue here.
Right, and you could also then take a look at how long until that starts impacting the performance. So when you do see that web server time increasing, small amount might be okay. So you can see what sort of overhead you can take, but then you can figure out what your breaking point is on those threads. Additionally, you mentioned a lot of the modules in IIS, and I think it's interesting. I love the elapsed time column in Dynatrace. I usually put that together with execution time and execution. So I can see, I usually have a bundle of those three together. But the fun thing is when it's taking time in the web server, it's always, you mentioned a lot of different kinds of modules, and something like compression is going to happen on the way out. So one thing you can do early as well, when you're looking at that time, using the elapsed time, if the elapsed time from the request, let's say it takes 1 second in the IIS web server portion of .NET, but the thread going from the web server portion to the app pool, the elapsed time is very short, then you know it's on the outbound side. Mm-hmm. And that can help you figure out where to start concentrating your efforts. So just bringing that up as in, and that actually ties into the last thing I wanted to bring up. You mentioned some other tool within IIS to help you see what's going on in those modules.
Mm-hmm. Yeah, that was
I never heard of that before. Can you expand on that?
Yeah, it's called, I hopefully got it right, Failed Request Tracing, FRT. If you Google for IIS, Failed Request Tracing, it's a tool that you can turn on. And I think it's typically should only be turned on for troubleshooting, but it's basically some native logging from IIS, and it shows you for your requests, not for all of them, for those that actually fail. That's why it's called failed request tracing. For those that are failing or very slow, it will give you a detailed breakdown on how these requests are actually handled by the individual native modules. So that's one thing. And what I heard, I'm not sure if I'm allowed to say that. I think I'll just say it because who cares? Our engineering team, obviously in Linz, Austria, is aware of the fact that this is a level of visibility that a lot of people would love. And the engineers on our web server agent, on IIS agent, are actually figured out a way to get this information now for every single request that Dynatrace is tracing for the pure paths. So it seems we're getting something soon in the upcoming Dynatrace.
That'd be awesome.
That would be very awesome, yeah, because this is a big blind spot for many. And I love what you said before. You said you're looking at the elapsed time, and depending on if the gap is between IIS and ASP.NET, or then on the way back, is it incoming request or outgoing? What I then also always look at is the request and response size. So in Dynatrace, you can actually capture request and response sizes both on IIS and also on the ASP.NET engine. So you can actually see, hey, this is a 2 kilobyte package. That's probably not big. Oh, it's a 2 megabyte package, and it has to go through compression and blah blah blah. Then it also gives you a little more information on where time might be spent. Yeah, so that's a great one. What I also like, maybe another one to mention, unless Brian, you want to say something. I can see.
No. I was just getting ready for something else.
Okay. One last thing. We told the audience to look at the elapsed time column, which is great. I also always enable the thread name column. So there's a thread name column in the PurePath tree that shows you actually which native and also which ASP.NET thread is actually involved in executing these things. Reason why this is very interesting, if you have not only native modules but also managed modules in IIS, I think, which are more and more common now, you can actually see the sequence of modules being executed and which threads are involved, and actually how many different threads are involved to process a certain request. That's also very interesting, and it becomes even more interesting if your code in the backend or in these modules is then spawning additional background threads because they want to do something asynchronously. So you're basically binding a lot of threads, doing something and waiting maybe on something that should actually be, these threads should be freed up for new incoming requests. So coming back to what you said, it's not only about adding more hardware on the problem and spawning up more instances, it's about optimizing the execution, the code that you have right now. And Dynatrace gives you all the visibility. That's pretty cool.
Right, but that's always the hard part, right? That's when you start getting into possible re-architecture, but that's what's needed to address these problems properly.
Yeah.
Right. So people might complain when they see what they're up against, but the trick is seeing what you're up against, having the tools to see that, and then getting it done. Because again, hardware is only part of the problem.
Yeah.
And obviously sometimes hardware is something that needs to be added. Having to add hardware can sometimes be a good thing, right? Because it could mean your business is so successful, your code is optimized, and you just have so many people, you need to have more hardware. But you should always be looking into that code optimization first, because otherwise you're just going to shoot yourself. You're kicking the can down the road.
Yeah, exactly. And especially if more and more people moving to cloud infrastructure, on the Microsoft world, it might be Azure. Then it's very easy to scale, right? I mean, they do the scaling for you. They just add more servers in the virtual land. But in the end,
add more charges to your account.
That's it. And at the end of the month, you figure out, wow, why do we have to pay 50% more if we only have 10% more users on the system? Oh, because the latest code deployment had a little secure, resource consumption problem. We're now consuming that many more CPU cycles, or we are blocking all of these threads. That's why IIS is spawning up all these worker threads, and so gotta be careful with that.
Okay, well,
what is that?
That means it's time for the Pure Performance Trivia No Prize.
Oh my God! And people,
question.
I know that most people don't even. Unfortunately, most people, well, nobody except me, can actually see you because I see you. I can see you in my Skype video chat. That's amazing.
Anyhow, yeah, it is. It's a little Korg monotron. Anyway, yeah, so I think we're done with the worker threads. It sounds like we are. I didn't mean to cut you off. But,
no, I just wanted to maybe sum it up. Maybe
yes.
This is what people.
So that was actually our summary. That was our summary, summing it up music.
Yeah, perfect. Okay. So from my perspective, what I encourage everybody to do is look at how many requests are coming in on IIS, how many threads are active on your ASP.NET engine. If you use Dynatrace, look at the elapsed time column. Look at the thread name column, so you can actually figure out on your critical transactions how many threads are actually involved and where is the time. Do you have a gap between IIS and ASP.NET? Then you know IIS has to wait to hand the request over to ASP.NET. If the gap is after ASP.NET, it's some of these native modules that need to handle a lot of bytes that are coming back to maybe do compression and stuff like that. Yeah. So that's something that you wanna look out for. And I think this is anything else do you want to add?
Nope, not to that one there.
Okay, maybe check out the blog. There. If you look at the
it's a good idea. What's the name of the blog?
It's called C# Performance Mistakes, and the full title is C# Performance Mistakes, Top Problems Solved in December. And that was basically a blog from January 14th, 2015. And it's on our apmblog.dynatrace.com.
Excellent. All right, so now we get to the trivia question. I would love to announce who won last week's question. But as we said before, this is recorded. This is the last of, I know I'm giving a little inside information here, but we are, in launching this podcast, we're recording several episodes before we launch, and this is the last of our goal. This is our 5th episode, and now our plan is to launch it. So we'll be a lot more closer to live once this one airs. Anyhow, so I can't announce the winner of last week's because it hasn't aired yet. We're still back in the future, but that will be posted up on the website. In the meantime, though, we have our new question. This time it's going to be from Andy. So, and Andy, I'll hand it over to you for this.
Yeah. So my question is, we discussed 3 questions with 3 options, and what I would
we only do one question.
I know.
Because there can only be one winner.
I know.
Oh, okay. I thought you said you're going to do 3
But the 2 of us, we discussed 3 options of questions that I ask, and I think I want to go with the second one that we discussed. So my trivia question is, what was the first programming language that I picked up? And it's not as simple as it's C or something. So it has to be very specific also on the platform. So what was the first programming language, and on which platform did I implement that program?
So we can already exclude C from that
we can exclude C but
we won't exclude anything else. But approximately what your I think maybe your first programming language might have been Ruby, right? You're 12 years old,
exactly.
I think.
Yes. No, I was. I think what to make it easier, not easier, a little tip. If you go to my SlideShare account, SlideShare.
And search through all of your slides, right?
Yeah, and some of them, in some of my presentations, I give a little intro to myself, to my person, and I actually covered my first computer that I ever had, and it was back in the late 80s, where I got this computer from my parents as a Christmas present. And it was, in the beginning, obviously, it was only about games. But then soon I realized there's some cool stuff on that thing as well. And so go to SlideShare, Grabner Andy, slideshare.com, or slideshow.com/grabnerandy, and then you will find maybe some of the slides that give you a hint of what my first computer was, and based on that, you just figure out what the most popular, very easy to use programming language was on that time.
Right. All right. And when you think you have an answer, tweet it to @Dynatrace, #PurePerformance, #NoPrize, KNOWPRIZE. And if you are the first person with the correct answer, your name will appear on the site saying you won. Isn't that exciting?
That is very exciting. I think it's exciting.
And if we ever meet you in person, we will also give you the privilege of buying us a beer.
Mm-hmm.
Of them buying us a beer, right?
Well, we
can't give out prizes. Well, no, we can't give out prizes.
That's true.
Real ones.
So they need to.
It'd be more fun if they win, they buy us one.
Yeah, it's more fun for us, definitely.
Yeah. Anyhow, moving on then. So hopefully good luck on that. And well, again, we're trying not to make them super easy Google answers. And I was thinking about this in between too, don't flood it with a million answers possible, because I'm sure there's going to be somebody out there who's just going to start tweeting every single programming language on every platform possible. Yeah. So please don't do that.
That's cheating.
If nobody wins, then nobody wins. And at some point, we'll reveal these answers. It will all be clear one day when Skynet takes over. Anyway, okay, so let's talk about the .NET. Speaking of Skynet, let's talk about .NET performance problems going into database.
Yep.
Right, and I think do we want to tackle the elephant in the room first, or should we talk about something else with database first?
I think the elephant in the room, you mean the n+1 query problem? Is that what you're talking about? Well, I think we should just talk about let's start in general, because maybe we'll figure out which areas we can cover. But in the end, it's going to be the n+1 query problem, because that's the number one thing we see out there, right? That's just the thing.
Well, let's talk about in general some of them, right? So there's obviously n+1, which you've heard us talk about before.
Yeah, but I think the bigger problem is, so the applications that Brian, you and I looked at, we always see. I think the trend is developers typically don't write their SQL statements on their own anymore, because most often it is hidden through a framework, right? Mm-hmm. What are the most popular frameworks out there?
Hibernate,
yeah.
Well, that's not.
No, Hibernate is perfect on .NET. Then the people we're using the AD.NET Entity framework to query entity objects from the database. We can use LINQ as the query language that then gets translated into some SQL that then is executed through AD.NET. But as a developer, typically I build my object model and then I develop against that object model, and that means that I often don't even know what's going to be executed. And this is actually, I think, one of the reasons why we see so many crazy things. And I'm just looking at the same blog post that I mentioned before, the C# performance mistakes, top problem solved in December. And the number one finding was 600 SQL executions each on a separate DB connection. That's even more interesting and more a good thing
more
to
awesome
optimize.
Than the n+1.
Yeah, well, it's n+1, but it's every single every single SQL statement on its own connection, which doesn't make a whole lot of sense. But
I do want to point out it doesn't always have to be n+1. I mean, as far as 600 transactions doesn't have to always be n+1. It could just be some really crazy query structure, or you could just be. I don't know what. Whatever. I don't know what I'm talking about.
Well,
you take over here. No, I'm just saying. It's quite often n+1 is the issue behind those large volumes, but every once in a while you'll get to something where people are just making ridiculous amounts of database queries against something, and it doesn't fit that n+1 pattern.
Yeah.
But it's just a ton of.
And an example would be if people are generating a report, or they're trying to get all the data they need for a very complex page, and then they are basically looping through different items, and then are grabbing something here, grabbing something from here and here and here. And in the end, as you said, you end up with hundreds and even thousands of SQL queries that. And in this case, I think it would make a lot of sense to say, well, you're just implementing business logic in your application, but it's very data specific. So why not move it to the database? Right? This is something where you would think about putting this stuff into a stored procedure.
Right.
Yeah.
And this is let's talk about these connections, right? Because the big problem, at least, that you looked at in that one blog, is not only are there 6,000 or not 6,000, I have seen queries where there are times when there were 6,000, but in this case, I believe it was 600, right? But they're each grabbing their own connection and there's no connection sharing. So what's going on in that situation?
In that
Explain
situation,
that a little.
Yeah, what I see is it's typically because the developers are using frameworks and then they are iterating through object lists. So they have a loop and they're iterating through objects. And every time they iterate through an object, they basically say, hey, nhibernate, or hey, AD.NET Entity Framework, give me the next object, and now give me the next object, and give me the next object. The way Hibernate implements it in a smart way, they say, well, if you need some piece of information, I will grab the connection, execute the statement, and release the connection again. So it makes sense because Hibernate doesn't know that you will ask me for the next 599 objects. So it is every time you call it, getting a connection, executing it, and releasing the connection again. So actually following one of the best practices out there of only holding on to a connection as long as you really need it. But what's wrong with this is that as a developer, if I know I need a certain set of records, I know I need the 600, then you can use these frameworks, whether it's Hibernate or whether it's Entity Framework or anything else you use. You can say, I know I need it, so give it all to me in one batch. That means opening one connection, execute one SQL statement that returns more than just one record, and then closing the connection again. So this is typically how it ends up like this.
And do these frameworks usually give you that option to reuse? And so to the listeners, he's shaking his head yes. So you do have the ability to reuse. But if you do set that setting, and maybe I'm getting a little bit too detailed here, but if you do set that setting, is that going to say reuse it? Well, is that going to be like a global thing? And can setting that reuse cause a problem later on with things that might not have such a large volume? Or do you have that kind of finessed control over it to say, in certain cases use that, in certain cases don't use that?
So I shouldn't have shake my head because I should have listened to the full length of your question, because what I was really meaning, because you said, you have the influence in reusing connections. What I really meant is instead of going through a loop and asking the framework 500 times in a row, give me the next element, the next, and the next. The option that I actually prefer is if you know that you need all of these 100, 500, or 600 objects in this case, why not say, hey, Hibernate, hey, Entity Framework, please, in one batch, query all of this data, give it to me then in a list, and basically an in-memory representation already of these objects, and then I iterate over it. That would be one option if you already know all of this. If you don't know up front how many objects you really need, then the option that you should have in these frameworks, depending on the framework you're using, you as the developer, you are taking a connection out of the pool, and then you're passing that connection into the framework itself and say, please reuse that connection, and I may call you multiple times, but reuse it on that connection. And when I'm done, I am responsible for returning that connection to the pool again. So with that, I'm not giving it to, I'm taking over responsibility and control of the connection. That's kind of
okay.
my thought.
Excellent. And the other option then as well is you were talking about turning something into a stored procedure instead, right? That's always and that could be a much better option in general.
Yeah,
obviously
exactly.
Everything.
And I think we are just shying away from that because as an application developer, if you don't have the background in SQL, but you know how to use these frameworks, you may not even want to write SQL. You don't want to write stored procedures. You may not even know about it. And therefore, it's just more convenient to use these frameworks. But sometimes you should sit down with your DBA, so with people that have more experience in database queries, and then say, is there a more efficient way so that I can get exactly the data that I need instead of me going 1,000 times to the database? Is there an efficient way where we can write something, a stored procedure, and then a stored procedure in the end gives me the results that I really need? And so that will help a lot, I think.
And it kind of sounds a lot, we talk a lot about the performance testers leveling up and learning different things. It almost seems like these frameworks put developers in a very similar situation where even with the N+1 query, where if you just use something out of the box as it is, you could have all these different problems. And you really need to, even as a developer, level up and understand what your framework is doing, why it's doing it, and figure out if that, in the end, if that is the better way to do it. Yep. Obviously, there's a lot of convenience that a framework's going to offer, and it really comes down to what does it give you, and what are the dangers, and going ahead and learning about what that is and seeing what it's doing in the background. So when you have your APM tool of choice in place, you can see what it's doing. You can see that those 600 connections being added, and get yourself to start asking questions.
And the reason why I think we ended up in this situation where we don't look behind the scenes right away is I was just at a meetup yesterday here in Boston, and great presentation from a guy from Couchbase. He was showing that database, and basically what he did, he presented how it works. And then in the workshop, we were all downloading a sample app, and we're deploying that sample app, and it worked. And it was amazing how easy it was. But I guess if you are jumping on the next framework and the next framework, and you just learn by sample apps, then it's very easy to fall into that laziness of saying, well, I just take the sample app and the code and the way they showed it to me, and then I just implement my app in the same way. And I don't need to, it's also fast, right? I mean, I don't need to worry about optimization. And then later down the line, you realize, wow, you have a performance and a scalability issue, even though you're now operating on a NoSQL database, but you're just using it the way a sample app used it, a travel app, or actually in this case, yesterday there was a travel app. It's, so really,
it was a travel app.
It was a travel. It was like
everybody loves a travel app.
Yeah, I know, it's amazing. Right? I mean, in this case, it was a flight. It was like, show me the flights from A to B. And it was a great example, but what I'm saying is, and what you also said before, sit down, use tools like Dynatrace or your APM tool of choice or your tracing tool of choice, and figure out what actually happens when you are implementing your key features. And if you are making the same round trip 500 to 600 times, it's probably not a good thing. And there's ways to optimize. And most of these frameworks have a lot of features, but these features are typically not shown in the Hello World example.
Right.
And that's what it is. Yeah. And yeah, so too many database queries on individual connections is a bad thing. Another thing that I see a lot is just querying too much data. So very executing SQL statements that return too much data that nobody really needs. So like, give me everything, and I figure out later if what I really need. That's kind of
right.
That's kind of the other extreme, right? Give me everything, which is not good. And another thing that I see a lot, what I see a lot, we typically talk about how many database statements are executed in a single transaction. But if you look at the lifetime of your app, or if you look at the at transactions that come in an hour, and if you see the same set of select statements being executed all the time, like give me the product information of this product, give me the price of that product, give me this and this static information or kind of static, then what do we do with this? I mean, what's the option? Cache, exactly, right? I mean, you need to figure out a way. We have a lot of cool frameworks out there that allow you to do distributed caching that work extremely well, also if there are updates. So try to cache the data closer to your end users and not always go to the database if the data doesn't change that much.
Right, and that almost sounds like some advice that would be given out 10 years ago, right? Because these in-memory caches have been around for quite a long time, and people have really been doing this for, again, 10, I don't know how long, quite a while now. Yeah. But you still run across this stuff all the time. And especially, once again, if you start using a framework and from a development point of view, you're not paying attention to these components, this is where your tools are going to help you see that information and be able to be a hero and say, hey, how come we're making a call for, again, store locations? Well, I guess store locations isn't too commonly used, but you get the point. Something that's very commonly used over and over again. Mm-hmm. Why isn't that being cached? I do want to talk a little bit about N+1, mm-hmm. right? Because we've been referencing it, but it's been a while. It's been a few episodes since we've talked about it, and in case people haven't heard us from the beginning, N+1 is probably one of the most common database issues that we see all the time, and This again is very, very visible when you're looking at a single transaction and you see the same query being run multiple times. Usually it's going to consume a large portion of your time, but even if it doesn't consume a large portion of your time, it's still inefficient. It might be leveraging connections, could be holding up threads, a lot of other things, right? But you're going to see a large number of times of the same query being made, oftentimes, and in most cases, it can be with the same bind variables, right? So it's a very, very problematic thing. And I think a good way to describe what an N+1 query is to kind of simplify it, make it, N+1 for, I don't want to say for dummies because that would include me, but, if you said, well, a good example that might happen in code, right? Where you say, give me a list of all of the student IDs, right? Pull back all the IDs for all the students. Now you have that list. And then in a separate query or, separate execution of code to a query, you say for each student, give me the hair color. Right. And now you're going to run through a list of, first you did a query which returned 10,000 rows. And now you're going to run through those 10,000 again, pulling another query for that instead of running a query. I think a better option would have been get me a list of student IDs and their hair color, exactly. Cross-joined with the hair color table. So you end up running a whole bunch of extraneous queries, throwing on a lot of extra time because these queries might only take 10 milliseconds. Right, it might be a really fast query, but in total on that entire transaction, this could take half a second, 1 second. We've seen some crazy examples of it, and it's probably one of the most common issues out there. You see it all the time. You are a mouthpiece against it, so let me give you a chance to speak on that a little bit too, especially in context of this .NET stuff. But I don't think there's really a Java or .NET context to N+1 queries, is there?
It's not. It's basically, as you said, I think you explained it pretty well, that it's just an access pattern, a bad access pattern. It's not only, I wouldn't even call it a problem. It's an access pattern which could become a problem, and the problem is that it's data-driven. That means the more results you have, the more often you go to the database with these round trips. And I know we always call it the N+1 query problem, but actually it should be called the other way around. It should be called 1 plus N. Because what you said, you start with one SQL query, say, give me the list of student IDs, and then in a loop, I go to every single student ID, and then make a query to get the hair color. So if you have 5 students in the database, who cares? If you have 10, who cares? If you have 10,000, you should care. But you should actually already figure this out earlier. And that's why, we talked about this when we did our load testing webinar or episode, when we talked about good data, right? We have to have good sample data or test data. And this is a clearly easy to identify data-driven problem. If you are testing a feature and you're testing it against a small sample database and then a larger production kind of like database, and you see the number of queries going up with the number of rows in a table, then you have a data-driven performance problem, and it's easily identified by looking at this N+1 query access pattern, saying, is the same SQL statement executed more than once in a transaction? And does this change over time the more data we have in the database? And for testers, I typically say, if you are a tester and if you're testing a feature that allows you to give input data, like in your case, the search, right? You're searching for people with the hair color gray or with the hair color, I wouldn't say orange, but I'm not sure who has orange hair.
Well, I guess they consider that red hair, but it's really orange.
Yeah. So basically what I wanted to say.
Clowns. Carrot top.
Of course.
Carrot top.
So basically what I'm saying is if you're a tester and you write the test for searching per hair color, you should execute the same test with different colors and then figure out, is there a correlation between the number of results and the number of database queries we're executing? Because if there is, it's a classical N+1 query access pattern problem. It's a data-driven problem.
Right. And I want to point out that everybody is susceptible to this problem.
Yep.
This is and I bring this up because I recall from a presentation you did in the past that when you started the whole kind of free trial and share my pure path and all this, you all had this exact problem on your data bank.
Exactly.
correct?
Yeah. On the backend system we use, so we store every person. We keep record, obviously, who registered and what they're doing, and I have a report that I can pull, and I can say, show me all the people that I've invited. And then we had the classical N+1 query problem using Hibernate. And the more people that ended up in our database because they registered for the free trial, the more queries were executed when I hit that report, and the slower it became. Yeah, that's actually a perfect point. Yeah, I had this.
And I want to point out that you did not write that code, though.
I did not write it. No, I did not write it, but I would have done it the same way. I would have done it the same way. Yeah.
You dropped in Hibernate. You think that's going to take care of it, and suddenly you find out you're susceptible too. So it's nothing if you do create a 1+n query problem. Don't be shy about it. No. It happens to everybody. It's okay.
Exactly.
Right.
Yeah, and I think there's probably more database related access patterns that we should watch out for. Actually, like 4 or 6 weeks ago, my colleague Harald Zeitelhofer and we had an article on InfoQ. And we talked about the different database access performance problems. So that might actually be another interesting one. It's called, it says diagnosing common Java database performance hotspots, because we focused on Java. But as we said in the beginning, it is the same for .NET as well. And we talked about exactly these problem patterns. We talked about prepared versus unprepared statements. We talked about connection pool exhaustion. So there's a lot of more stuff. But I think obviously we could talk forever. But I think for this episode, I think we hit on the most common ones, I would say.
Right. And we will pick more of these up in the future. Do you want to anything you want to summarize about the database, or was that your summary right there?
Yeah, the summary is don't think you always know what's really going on, especially if you go through frameworks. Don't think you should not know about it because you have to. So I think you should, every time when you pick up a new framework, a new language, or anything new, as a good developer and as a good architect, it should be in your best interest to understand what these frameworks are actually doing and go beyond the Hello World example and beyond the travel apps example. That's just very important. To understand what are your use cases and how can you, in an optimal way, query the data that you need without going too crazy on the database.
Yes, and I would like to add to that as well I think your advice is really good for the development teams who are working on these. And for the performance teams, I would like to add to, really start looking at the data, so you start becoming familiar with what these patterns look like. There are some great examples on the blogs that Andy has written, so you can see the visual along with it. But get familiar with these, because these are going to probably be some of the most common things you're going to see over and over again as you're running those tests. And the more you know, the smarter you can be, the more part of that broad team you can you can be a great contributor and really show people that you know what you're doing. And the most important thing is just really helping get that code out there. So there's a lot for everybody to learn about this. There are a lot of metrics, as we've covered over and over, to help you see these things. So keep your eyes sharp and keep learning for everybody, developers too.
Yeah,
right.
Exactly.
Everybody has to learn.
Yeah.
All right. So if you have any other questions, suggestions, show ideas, or anything, feel free to send us an email at pureperformance@dynatrace.com. You can also reach us through the Dynatrace Twitter, which is just at Twitter. I would add the hashtag pureperformance. If you wanted to follow us or communicate with us directly, my Twitter handle is Emperor Wilson, EMPERORWILSON, because I am the emperor in my head. And Grabner Andy, that's GRABNERANDI. That's Andy's Twitter. I could have let you said that, but you can say it please repeat that for the for my funny accent.
So my Twitter handle is at GrabnerAndy, GRABNERANDI. I'm very particular on the I on the end and not Andy with a Y. And I think I'm really looking forward to some feedback on other topics that we should cover. Also, very happy to take people on the show. Right, we want to interview people.
Right.
That would be awesome. We already have some cool names in here, and we already have some topics that came in over the last couple of weeks once we started kind of advertising the stuff that we're doing with our readership and with our followers that hopefully will be followers. But yeah, a lot of cool stuff coming.
Yeah, I was talking to Mark a little bit about the early days of Perf Bites. That's Mark Tomlinson. Perf Bites is another performance blog. He inspired us to start this one up. But his original idea for the show, have you ever heard the show Car Talk?
Yeah.
It was on NPR. It was those two guys from Boston.
Yeah.
So he was telling me that was their original plan for the show, to hopefully have it some kind of call-in thing. Obviously, that doesn't work too well in the podcasting thing and trying to do things live. But it does bring up to the point of, I see where he wanted to go. It would be great to be able to have any of our listeners be able to contribute to the show, to be able to come in and tell us about some of the great things they've seen and or solved, or crazy problems they've encountered. So do, as Andy said, please contact us if you have anything you want to add to the show. If you want to be a guest on the show and talk about things, we'd love to have you on. Just wouldn't be live, and we don't have the funny accents. Well, different funny accents we have, I guess, but not the Boston accent. We love Boston.
I was in Washington yesterday at a conference and presented, and I started out and I said, "Where do you think I'm from?" And the first guy said, "You're from Boston." I said, "Really?" Because I guess I don't know. I picked a word like idea. Car or idea. I think I said idea with the R in the end, where there's no R in idea, as we know. But he picked it up. I said, well,
so that's very astute, picking up the Boston accent underneath the Austrian accent.
Exactly.
That's quite complex. Anyhow, thank you, everybody. We'll wrap up today's show. Big thanks to everyone for listening, as always.
Thank you. Talk to you soon.
Goodbye.
Keep happy Cinco de Mayo, belated, as we said, right?
Yes, happy Cinco de Mayo. Hope you were safe. Yeah. And if not, you might not be listening to this.
Hopefully you sobered up until now.
Yes. Goodbye, everyone.
Bye.